We are beginning to enter the third stage in the evolution of the computer. No longer computing on transistors, computing on atoms. This is the ultimate computer. You can't do better than that. Computing on atoms. And that's what the quantum computer is all about. They exist already. They are millions of times more powerful than our most powerful digital computer on certain tasks. So, there's a race between China, between IBM, Google, Microsoft. A race to see who can get the first all-purpose quantum computer to put on the marketplace, which will change everything. Google's quantum AI just crossed a threshold no one thought was possible. And now, physicists are whispering one word: mass. If quantum AI can change mass itself, even in a localized, digital, or effective way, the rules of reality may no longer apply. And Michio Kaku, he says this could be dangerous. This isn't just science fiction theory. From Casimir vacuum manipulation to AI-designed metamaterials that behave like massless matter, we now have systems behaving in ways never seen before. And they're being guided by AI. Google's Willow quantum chip can solve problems in minutes that would take classical supercomputers billions of years to crack. When quantum computing merges with artificial intelligence, we enter uncharted territory where the fundamental properties of matter itself could potentially be manipulated. But what's the real story behind these claims? And just how concerned should we be? That's what we're diving into today. Breaking Quantum AI explores mass as a variable. Google's quantum AI isn't just solving complex problems anymore. It's potentially opening doorways to entirely new frameworks where mass itself could become a programmable variable. We're entering a realm where the fundamental properties of matter might be manipulated in ways previously thought impossible. In 2024, Google unveiled their groundbreaking Willow chip, a 105-qubit quantum processor that completely shattered our expectations. This quantum marvel executed a benchmark calculation in just under 5 minutes that would take today's most powerful classical supercomputers an estimated 10 to the power of 25 years to complete. That's not just millions or billions of years. We're talking about a time frame longer than the universe has existed. But here's the catch. With this kind of power, AI isn't just simulating physics. It's starting to rewrite its own rules. Let's break this down clearly. What does it mean to alter mass? We're not talking about picking up a dumbbell and putting it on a scale. We're talking about modifying what gives something resistance, inertia, its identity in space. And here's where it gets weird. Engineers have already created materials where electrons move like they have no mass. Now imagine what happens when AI designs that material from scratch. Scientists at Penn University have already developed metamaterials where electrons behave as if they have near zero mass. And in other labs, researchers have created ultra-cold quantum fluids that exhibit negative effective mass. Push them one way and they accelerate in the opposite direction. These aren't theoretical concepts. These are real experimental results happening right now. What if Google's quantum AI could take these concepts further? Could it discover new configurations of matter where mass becomes a tunable property rather than a fixed constant? The implications would be staggering. Let's explore 5 mind-bending theoretical routes that could potentially lead to altering mass, possibilities that become increasingly plausible when guided by quantum AI systems like Google's. At the most fundamental level, particles get their mass from how strongly they interact with the Higgs field, the invisible energy field that permeates all of space. What if quantum AI could discover methods to locally modify how particles couple with this field? Even slight adjustments to this interaction could theoretically change how matter responds to forces. It would be like turning a dial that controls the very essence of mass itself. Here's where physics gets truly bizarre. The vacuum of space isn't empty. It's a bubbling sea of virtual particles and energy. The Casimir effect already proves we can manipulate vacuum energy between plates. If quantum AI could design configurations to shift vacuum energy density locally, it might create pockets where inertial properties change. This isn't science fiction. It's an extension of experiments already happening in advanced physics labs. This is where Google's quantum AI may already be making significant headway. Engineers have created materials where electrons behave as if they have zero mass. At the University of Pennsylvania, researchers developed structures where electrons move as if weightless in one direction. Quantum AI could potentially design even more exotic materials, substances where particles respond to forces in ways that defy our conventional understanding of mass, creating environments where effective mass becomes programmable. General relativity tells us that mass warps space-time. But what if we flip that relationship? NASA's gravity probe B already measured frame dragging, where rotating masses drag spacetime. Advanced quantum systems might find ways to artificially induce localized spacetime curvature effects, potentially altering how objects experience inertia in those regions. It's like changing the rules of the game rather than the players. This is perhaps the most speculative yet fascinating possibility. Quantum AI systems excel at modeling particles in virtual environments. As they simulate lattice gauge theories, they might discover entirely new types of particles or states of matter with tunable mass properties, quantum entities that could potentially be realized in laboratory settings, opening doors to mass manipulation we've never imagined. Each of these paths bends reality, but one of them may already be in the hands of AI, whether we're ready or not. If AI just stepped over the line of controlling mass, what happens next? Like and subscribe so you don't miss what we uncover in the next segment, and comment below. What do you think it means to change mass itself? The implications could transform everything from energy production to space travel or create risks we've never encountered before.